Good morning, students. Today we are going to see Cambridge Assessment International Education Chemistry A Levels Paper 4. This is a 970142 Feb March 2022 series. So for A Levels Chemistry we have 100 marks paper. So for this 100 marks, organization is very important, and we will directly jump to the question number 4 where the organization is there. So I will tell you quickly how to solve the organic questions. So very simple, they have given here two compounds, compound F and J, and they have asked the question. The question is F and J contain the arene functional groups. Identify the other functional groups which are present in F and J. So other functional groups, if you see here, so in this you can see this is the carboxylic acid. So here you can write it's carboxylic acid. So this is one functional groups. Another, here you can see this is the benzene ring, to that OH is attached, so this is called as the phenol is our functional group. And if you see this chain, so this is like carbonyl carbon attached with another carbon which is connected to another R. So this is your ester. So this is your ester functional group. So in J we have phenol and ester as a functional group, whereas in F we have carboxylic acid, and you can see something is also attached, NH2, to this benzene ring. So this is called as aniline. Sorry, this is called as amine. Okay, this is called as the amine, and this amine is attached to this benzene ring which is called as a phenylamine. So okay, so benzene ring is known as phenyl and it is known as phenylamine. What is aniline? Aniline structure is different. Aniline is what? When you have a benzene ring and NH2 is attached, this is called as the aniline. This is called as the aniline. Okay, so F and J contain arene functional groups, and identify the other functional groups. So F, we have two functional groups. One is phenylamine and carboxylic acid, and in J we have phenol and ester. These are the two functional groups. Okay, now next question is what? State the number of chiral centers in the molecule F and J. Now look at the molecule F. Now what is the chiral center? Now chiral center is what? The carbon atom to which the four different groups attach. That four different groups is different. Okay, now we need to identify the carbon atom. So suppose this is my carbon atom. So all four groups attach. So this is X, Y, Z and W. So this carbon is called as the chiral carbon atom. Very simple. Now if you see my structured one, there is no any chiral carbon atom. I just erase the remaining part. So there is no chiral carbon atom. If you see the structure, there is no chiral carbon atom. Okay, now what is the chiral carbon atom? We want all four different groups. Now in this structure, if you see here, I have one hydrogen, correct? Here also hydrogen, here also hydrogen, hydrogen. Here is there is no hydrogen, there is no. Now we came to know that there is no chiral center, in F. Now come to the structure J. Now look at the molecule carefully. Chiral center means what? We want four different groups to this carbon atom. Very simple. So I can write here A, B, here D and E. So such a molecule A, B, C, D. So this is my chiral carbon, correct? Now you have to identify. Now can you see this carbon? So here we have one proton. So this is my methyl, correct? Now if you see this is CH2, but we can go to the next carbon atom. This is attached to another 2 methyl. So this is attached to this carbon atom. So this is my one chiral center. Now if you see this molecule, here also I have one hydrogen. This is like CH2, but next carbon is attached to another CH3, and this is also attached to. So here I have total, in J structured, I have total 2 chiral center. Is this clear to you? This cannot be chiral because here I have 2 hydrogens. This cannot be chiral because here I have 2 hydrogens. This cannot be chiral because here I have 2 hydrogens, and this cannot be chiral because here I have 2 methyl groups. So in my structure I have 2 chiral center. Is this clear to you? So this question is very simple, and they ask about the chiral. So the chiral concept we have already done in AS. Okay, so you will get the 2 marks easily. This question carries 1 mark, sorry. Now, next question B, they have given a student proposes a multi-step synthesis of F from benzene as shown in the table 4.1. The complete table 4.1 providing relevant details of reagent and conditions of the step 1 and 4. Now they have given an organic reactant, so this is the benzene, and they have asked the reagent and the conditions. Now if you see the reactant and the product, what is the difference? So in the reactant we have a benzene, and in the product something is attached that is called as your CH3. So reagent here, this is called as the your electrophilic substitution of methyl on benzene. So here your reagent will be, your reagent is CH4. Your reagent is CH4. This is the CH4, and this will take place in presence of Lewis acid, that is called as a AlCl3. Okay, AlCl3. So AlCl3, this is your Lewis acid. Okay, so this is your Lewis acid. Okay, which catalyze the reaction. Second, that methyl. So what is this? What is the name of this product? This is called as the toluene. This is called as the toluene or methyl benzene. Okay, this is called as the toluene or methyl benzene. Now next they have given the same thing. You have to just I'm scrolling down. So methyl benzene, you are reacting with concentrated HNO3 and concentrated sulfuric acid. Now this HNO3 and H2SO4, they react. Okay, this HNO3 and H2SO4, they react and they produce a nitronium ion, that is our electrophile. Correct. Now this methyl benzene or toluene, this is what methyl group is, what electron donating. So this will donate the electron at this ortho positions and this para position. So this my 2 ortho and 1 para position become electron rich. Okay, and I will get the product at the D. So my product at the D will be, so this is the my benzene ring. At this axis I have this CH3. So at para position I will get electrophilic substitution, that is called as the 4-nitro methyl benzene or 4-nitro toluene. So this will be my product D. Okay, so in the subsequent question they may ask write the structure of D. Now next they have given hot alkaline KMnO4, then dilute H2SO4. Now hot alkaline KMnO4 and dilute H2SO4, this will oxidize this methyl part to the acid. So this is your simple oxidation. Okay, this is your oxidation, that methyl part is converted to the acid. Now what is the next? They have given here another product. This is like your nitro, like 4-nitro benzoic acid. What is the name of this compound? This is the first position. So this is carbon number 1. We always give the priority to the functional group. So this is a 1, this is 2, this is 3, and this is 4. This is called as the 4-nitro benzoic acid. Okay, so this name is what? 4-nitro benzoic acid. Okay, now they have given your condition and they have given one product. So if you see what is the difference, so nitro became aniline. So what is this? This is simple reduction. This process is what? Reduction. And nitro to NH2, there is one simple reduction reagent. This is SnSCl, reduction in presence of SnSCl. Nitro group is converted to the NH2. So this is very simple reduction they have given. Now what they have given here? Now they have asked here, in second multi-step synthesis, student changes the order in which the reagents and the conditions are used. So they have given here benzene. Benzene reacts with something and we get methyl is attached. Then hot alkaline KMnO4, we get the acid. Concentrated ratios of we get the G. So this is what. Now what you have to do, you have to use this table. Okay, look at here. In second multi-step synthesis, you have to use this table. So here obviously your hot alkaline KMnO4 and H2SO4 will oxidize the methyl part and you will get the benzoic acid. So name of this product is what? So this is what your benzene, this is your benzene, this is your methyl benzene. Okay, just put the word methyl. Here is what your benzoic acid, correct? Benzoic acid. Now same thing you are doing, concentrated HNO3 and H2SO4. Now this produces your nitronium ion. Always remember, concentrated H2SO4 and concentrated HNO3 and H2SO4 produces the nitronium ion, NO2 plus. Now this is your carboxylic acid, this COOH, this is electron withdrawing group. So this benzene ring, look at here, this benzene ring, if COOH is attached, it withdraws the electron density away from the benzene. So at ortho position and para positions, the electron density is very less. So, but we are generating this nitronium ion. This is also electron deficient. So this nitronium ion cannot go to the ortho and para position. So ortho and para positions are already electron deficient. So compared to ortho and para, the electrophilic substitution will take place at meta position. So this is the meta position. So at either of these two sides, your NO2 will be attached and you can write like this is M nitro or 3 nitro 3 nitro benzoic acid. Is this clear to you? So they have given here structure. Draw the structure of G. So the structure of G we can write like this. So what is the structure? So structure will be your, let me select the pen. The structure will be your, this is the benzene ring, this is COOH, because it is electron withdrawing at meta position. Sorry, this is your nitronium. Okay, this is your nitronium. So I wrote methyl. So this will be your nitronium ion at this meta position, correct? So this will be your product, and they have asked explain why this is the major product, explain why the G is the major product. So same explanation you can give that COH is the electron withdrawing group which withdraws electron density from the benzene ring. So that is a minus I effect, and the electron density is comparatively more at meta position compared to ortho and para. So electrophilic substitution takes place at meta position. Okay, so this